Welcome on MGSS YouTube channel. My dear student, in last video I taught you that different types of polygons. In this session I will discuss the types of the polygon. And in this at first I am going to discuss about the different types of polygon on the basis of their shape. Because when you discuss about the different shape of the polygon, I have just taken one example. You know that this polygon is a type of quadrilateral and it is made up of 4 line segments. And this can be drawn by this way also. Actually, these line segments are also made up of, you can just see that this figure are also made up of 4 line segments. The same line segments AB, BC, CD and AD, and one of the arrangement you can just see that I have just taken the same name to make you clear that AB, BC, CD and AD or DA. The same naming I have just done. Both the polygons are made up of same line segments, 4 line segments, same number of line segments. Whatever, these two figure have different shape, and it is due to that you can just classify it on the basis of angles or diagonals draw. 2 ways you can just define, and these 2 different figures are, one of the figure is concave and second figure is known as convex. Concave and convex, and it can be defined on the basis of the angle, and the second one on the basis of diagonal. One by one I am going to discuss diagonal and angles. First one I discuss on the basis of angles. What you have just noticed in both the figures, you can just see in this figure all angle, each angle of this figure is less than 180 degree. You can just see that all such figure, because you know that if the angle is 180 degree, then it must be a straight line with the initial point. Suppose that this is the figure A, B. You can just see that this angle is 180 degree. But if any figure has been drawn between this OA and OB, between these 2 rays meeting at a common point O, then it is less than 180 degree. And in case of obtuse, if angle is more than 180 degree, then it must be more than the straight angle. Then this angle is actually more than 180 degree. If you check in this figure, each angle is less than 180 degree. But if you check in the second figure, then you can just see that this is less than 180 degree. This one is less than 180 degree. This one is less than 180 degree, but this one angle, this is more than 180 degree. And on the basis of it, you can define concave and convex figure. My dear, convex, such figure whose each angle is less than 180 degree, this is known as convex figure. And all such angle which is greater than, if one of the angle, not all, it is not essential that all, if one of the angle, at least one of the angle is greater than 180 degree, then such figure is known as concave figure. Understand? And this is why you can just check that a quadrilateral has 4 angles, And you know that in this figure, it has four different angles are A, B, C, D, and each angle is less than 180 degree. So this figure is convex figure, and whatever you can just see in this case, it has also four angles. Three angles are less than 180 degree, but one angle is greater than 180 degree. And by the definition of concave, if any one angle is greater than 180 degree, then that figure must be, the polygon must be concave polygon. So this is a concave polygon. My dear students, so it is clear that this is convex and this is concave. And some more example, you can just see that these two figures that I have just drawn, it is a type of concave. Why it is a type of concave? Because at least one angle must be greater than 180 degree, and you can just see that this is less than 180 degree, less than 180 degree, less than 180 degree, less than 180 degree, but this angle is greater than 180 degree. Similarly, you can just see that this angle, this angle, this angle, this angle, and this angle. All these angles are less than 180 degree, but at least one angle is greater than 180 degree. Then this figure is known as concave polygon. Understood? And in this case, you can just see that each angle is less than 180 degree. And also in this case, you can just see that each angle is less than 180 degree. So it is known as convex polygon. It can be explained by another way also, on the basis of the diagonal that is drawn. A diagonal, you know very well that the line segment which joins non-adjacent vertices. The line segment which joins non-adjacent vertices means no regular vertices. Then it is known as diagonal. And in case of coordinator, you know that the line segment which joins BD in this case or AC is known as diagonal. Why? Because A and C are non-adjacent vertices. B and D are non-adjacent vertices. I have already discussed in the previous videos. So you can just see the previous video regarding the definition of the diagonals, my dear. Here, if you draw the diagonals, then it can be defined on the basis of diagonals. And in case of convex, each diagonal must be in the interior of this figure. Any one of them that you have to draw must be in the interior. All the not anyone. Anyone cannot be in the exterior part of this figure. All the diagonals must be inside this figure. You can just draw the diagonal. I have just drawn the different diagonals, and you can just see that all the diagonals that you draw must be inside this figure. No one, not a single diagonal be in the exterior part of this diagonal, but this figure. Similarly, you can just see in this case, each diagonal is inside this figure. Each one is inside. Whatever, in case of concave polygon, if you draw, then at least one, more than one may possible, but at least one diagonal must be in the exterior part of this polygon. If you draw, then you can just see that all the diagonal that you draw must be in the interior part. One of them, when you draw, then this diagonal is in the exterior part of this figure. Similarly, all the diagonals are inside this figure, but one diagonal one diagonal I have just drawn with the dotted lines. This diagonal is in exterior part of this figure. So you have to just keep in mind two definitions of concave and convex. On the basis of angles, if each angle is less than 180 degree, then such polygon is known as convex polygons. If one of the angle is greater than 180 degree, then it is known as concave polygon. And second definition, on the basis of diagonal, if all diagonals are inside the figure, then it is known as convex polygon. If one of the diagonal is outside of this figure, then it is known as concave polygon. At least one of the diagonal is in exterior part of the polygon, then it is known as concave polygon. Thank you very much and keep watching MGSSC YouTube channel and hope you have to enjoy this session. Thank you very much.